The Atlantic Ocean, March 1943. Kapitänleutnant Friedrich Steinhoff peered through the periscope of U-432, his experienced eyes scanning the dark waters above. He had been hunting Allied convoys for 18 months, sinking 12 merchant vessels and evading depth charge attacks that had destroyed so many of his fellow submarine commanders. He knew the patterns, understood the tactics, and had survived encounters that would have sent lesser captains to the bottom of the ocean. But nothing in his training, nothing in his 2 years of combat experience had prepared him for what was about to happen in the next 90 seconds. Steinhoff heard it first. Not the familiar splashing of depth charges being rolled off the stern of a destroyer, giving him precious seconds to maneuver and dive deeper. This was different. A series of rapid, almost musical splashes in quick succession, like someone skipping stones across a pond. 24 distinct impacts on the surface above him, arranged in a perfect circle around his boat's position. He had never heard anything like it before. His first officer looked at him with questioning eyes, waiting for orders, waiting for the captain who had always known what to do to tell them how to survive this new threat. The detonations came simultaneously, not the rolling thunder of depth charges exploding one after another as they sank to preset depths, but an instantaneous ring of fire that erupted all around U-432. The boat's hull screamed as 24 shaped charges, each weighing 35 pounds of Torpex explosive, detonated on contact with the submarine's pressure hull. The forward torpedo room flooded in seconds. The control room crumpled like paper. Steinhoff's last thought was one of complete confusion. How had they known his exact position? How had the charges reached him so quickly? Why had there been no time to evade, no time to go deeper, no time to do anything but die? This was the Hedgehog anti-submarine mortar, and it was rewriting the rules of underwater warfare in ways that German U-boat commanders literally could not comprehend until it was too late. For years, the Battle of the Atlantic had been the longest continuous military campaign of World War II, and for much of that time, the U-boats were winning. But the introduction of the Hedgehog in 1942 marked a turning point so dramatic, so revolutionary, that it would help tip the balance of the entire war. To understand why the Hedgehog was so devastating, you have to understand what came before it. When World War II began, the primary anti-submarine weapon was the depth charge, a technology that had barely evolved since World War I. These were essentially large drums packed with 300 to 600 pounds of explosives, fitted with a hydrostatic fuse that would detonate the charge at a preset depth. The attacking ship would sail over the estimated position of a submarine and roll these charges off the stern or launch them from side-mounted throwers called K-guns. The depth charge was better than nothing, but it had fundamental flaws that gave experienced U-boat commanders a fighting chance. First, the attacking ship had to pass directly over the submarine's position, which meant the destroyer or corvette lost sonar contact just when it mattered most. Sonar, or ASDIC as the British called it, worked by sending out sound waves and listening for echoes bouncing back from underwater objects. But when a ship passed over a submarine, the sonar beam couldn't angle downward sharply enough to maintain contact. The submarine disappeared from the scope for crucial seconds or even minutes. This gave U-boat captains a window of opportunity. An experienced commander like Steinhoff knew that the moment sonar contact was lost, he had perhaps 30 to 60 seconds before the depth charges would reach his depth. In that time, he could order flank speed, change course radically, and try to slip away from the pattern of explosives raining down from above. It was a deadly game of three-dimensional chess, but it was a game that could be played and sometimes won. The second major flaw of depth charges was their lack of precision. Because they had to be set to detonate at specific depths, and because the attacking ship had lost contact with the target, depth charge attacks were fundamentally based on estimates and guesswork. The destroyer captain would calculate where he thought the U-boat was heading, set his charges to detonate at the depth he believed the submarine had reached, and hope for the best. A U-boat only had to be 50 feet away from a depth charge to survive the blast. Any further, and the explosion would cause only minor damage or none at all. This meant that depth charge attacks required large numbers of explosives. A typical attack pattern might involve dropping 20 to 30 depth charges in a grid formation, hoping that at least one would detonate close enough to damage the submarine. Most attacks failed completely. Statistics from early in the war showed that it took an average of over 200 depth charges to sink a single U-boat. This was wildly inefficient, requiring ships to carry enormous quantities of explosives and often exhausting their supply after just a few attack runs. The psychological aspect was also important. When a depth charge attack began, the submarine crew could hear the splashes as the charges hit the water above them. They knew what was coming. They could feel their captain maneuvering the boat trying to evade. The charges would take time to sink, building tension but also giving the crew hope that their commander's skill might save them. Then the explosions would come, sometimes close enough to throw men against bulkheads and shatter light fixtures, sometimes distant enough that they seemed almost harmless. It was terrifying, but it was survivable. Experienced crews learned to trust their boats, their captains, and their ability to endure. The experienced U-boat commanders had developed an almost sixth sense about depth charge attacks. They could estimate the speed of the attacking ship by the sound of its propellers. They could judge the pattern of the attack by counting the splashes and timing the intervals between them. They knew that corvettes typically carried 40 to 70 depth charges, while destroyers might carry 100 or more. They understood that after the first pattern was dropped, there would be a delay while the attacking ship circled around to make another run, giving them time to maneuver and perhaps escape in the confusion. Some U-boat captains became legendary for their ability to evade depth charge attacks. Captain Lieutenant Otto Kretschmer, one of Germany's top aces, survived dozens of attacks through a combination of nerve, skill, and intimate knowledge of his boat's capabilities. He would sometimes order his submarine to dive deep and lie motionless on the ocean floor, letting the attacking ships lose contact and move on. Other times he would use the thermal layers in the ocean, areas where cold and warm water met, to create false sonar echoes that confused the hunters above. The cat-and-mouse game between U-boats and Allied escorts had become highly sophisticated by 1942. U-boat commanders knew that if they could survive the first few minutes of an attack, their chances of escape improved dramatically. The attacking ship would be running low on depth charges. Its crew would be fatigued from the stress of combat. The submarine might have moved far enough away that sonar contact became intermittent. Time was on the U-boat's side, and patience was a virtue that could save your life. But the Hedgehog changed everything. This weapon was so different, so revolutionary, that it invalidated years of hard-won experience and tactical knowledge. Instead of dropping charges behind the ship as it passed over the target, the Hedgehog threw 24 small projectiles forward ahead of the attacking vessel. This single change had cascading effects that made the weapon devastatingly effective. The Hedgehog launcher looked like something from a medieval siege engine crossed with modern technology. It consisted of 24 spigot mortars arranged in 4 rows of 6 mounted on the foredeck of destroyers, corvettes, and frigates. Each mortar held a projectile that weighed about 65 pounds total, with 35 pounds of that being Torpex explosive, which was 1.5 times more powerful than TNT. When fired, the projectiles arced through the air like a fireworks display, splashing into the water about 200 yards ahead of the ship in an elliptical pattern roughly 40 yards in diameter. The design of the Hedgehog launcher itself was a masterpiece of practical engineering. The spigot mortar system used a central rod, or spigot, upon which each projectile sat. Inside the launcher, a small propellant charge would detonate, launching the projectile up and forward in a carefully calculated ballistic arc. The arrangement of the 24 mortars was precisely calibrated, so that despite being fired from a fixed position on the ship's deck, the projectiles would land in an optimal pattern that maximised the chance of at least one striking the target. Here's where it got clever. Unlike depth charges, which detonated at preset depths regardless of whether they hit anything, Hedgehog projectiles only exploded on contact with a solid object. If they missed the submarine, they simply sank harmlessly to the ocean floor. This meant that when a Hedgehog salvo was fired, there were only 2 possible outcomes. Either there was silence, meaning the attack had missed, or there was an explosion, meaning at least one projectile had struck the submarine's hull. This contact detonation feature was psychologically devastating to U-boat crews in ways that went beyond the immediate physical threat. When depth charges were being dropped, the submarine crew experienced a series of explosions regardless of whether the attack was accurate. The noise, the concussion, the shaking of the boat, all of this created an experience that was terrifying but also paradoxically reassuring. If you were experiencing explosions and your boat was still intact, you knew you were surviving. You had endured the attack. You were still alive. With the Hedgehog, there was only silence or death. If you heard the splashes of projectiles hitting the water above you, and then nothing happened, you knew the attack had missed. But you also knew that the attacking ship still had sonar contact, still knew exactly where you were, and would be lining up another salvo in less than a minute. The ship hadn't lost you. It was still hunting, still tracking, and it would keep throwing those deadly projectiles until one of them found its mark. The crew of a U-boat under Hedgehog attack experienced a unique form of psychological torture. They would hear the splashes, distinctive and numerous, and then they would wait in absolute silence. No explosions meant they were still alive, but it also meant the hunter was still there, still tracking, preparing to fire again. The men would look at each other in the red emergency lighting of the submarine's interior, seeing their own fear reflected in their comrades' faces. Some would pray. Others would grip whatever was nearest to them, knuckles white with tension. All of them knew that the next salvo might be the one that found them. And if you did hear an explosion, you probably didn't hear anything after that, because one hit was usually enough. The Hedgehog projectiles were specifically designed to penetrate a submarine's pressure hull before detonating. The shaped charge would punch through the thick steel, and then the torpex would explode inside the submarine. This was catastrophic. A depth charge exploding near a submarine created a shockwave in the water that could crack the hull or damage systems. A Hedgehog projectile exploding inside the submarine meant instant flooding, structural failure, and almost certain death for everyone aboard. The forward-throwing capability was the other revolutionary aspect of the Hedgehog. Because the projectiles were launched ahead of the attacking ship, the destroyer or corvette could maintain continuous sonar contact throughout the entire attack. The ship never had to pass over the submarine and lose the target. This meant attacks could be aimed with real precision instead of guesswork. The sonar operator would track the U-boat's position and movement right up until the moment the Hedgehog was fired, giving the weapons officer accurate targeting data. Think about what this meant for a U-boat captain. For years, they had relied on that crucial moment when the attacking ship lost sonar contact. That was when they could maneuver, when they could use their knowledge of the ocean, their boat's capabilities and their own skill to slip away from the pattern of falling depth charges. But with the Hedgehog, that moment never came. The hunter never lost sight of its prey. The U-boat remained pinned on the sonar scope like a butterfly on a board, and the projectiles rained down with methodical precision. The speed of the attack was also crucial. Hedgehog projectiles travelled through the air much faster than depth charges sank through water. From the moment of launch to impact, only a few seconds elapsed. A U-boat at periscope depth, about 60 feet down, would be hit by Hedgehog projectiles in less than 10 seconds after they splashed into the water. Even a boat at deeper depths would be struck in under 30 seconds. This was far, far faster than the minute or more it took for depth charges to sink to operational depths. This speed eliminated the U-boat captain's manoeuvring window almost entirely. By the time the crew heard the splashes and the captain ordered evasive action, the projectiles were already sinking toward them at speed. There was no time to turn, no time to go deeper, no time to change speed. You were where the sonar said you were, and the Hedgehog was already on its way. The mathematics of evasion help explain why the Hedgehog was so effective. A Type 7 U-boat, the most common German submarine of the war, could make about 17 knots submerged for very short periods, but more typically cruised at 4 to 6 knots when underwater to conserve battery power. Even at flank speed, in the 8 to 10 seconds it took for Hedgehog projectiles to reach a submarine at periscope depth, the boat could move at most 50 to 75 yards. But the Hedgehog pattern was 40 yards in diameter, and the attacking ship's fire control could predict the submarine's movement and adjust the aim point accordingly. The numbers simply didn't work in the U-boat's favour. The first U-boat captains to encounter the Hedgehog had no idea what they were facing. They heard the unusual pattern of splashes, so different from depth charges, and tried to react with their standard evasion tactics. It didn't matter. The projectiles found them anyway, and the first they knew about the weapon's contact detonation feature was when their hull was breached and the ocean came pouring in. Word spread slowly through the U-boat fleet. Survivors were rare because the Hedgehog was so effective that it usually killed everyone aboard the target submarine, but occasionally a boat would survive an attack, or a U-boat commander would observe from a distance as another submarine was destroyed. The reports that filtered back to U-boat headquarters described a new Allied weapon that seemed almost impossible, projectiles that only exploded when they hit, attacks that came from ahead of the hunting ship. No time to evade, no warning, just sudden destruction. One of the few detailed reports came from Oberleutnant zur See Hans Weber, commander of U-boats who survived a Hedgehog attack in June 1943. His boat had been pursuing a convoy when a British corvette detected him and began an attack run. Weber heard the distinctive multiple splashes of what he would later learn was a Hedgehog salvo. He immediately ordered maximum dive and a hard turn to port, standard evasion tactics that had saved him before. Nothing happened, no explosions. Weber and his crew waited in tense silence, expecting depth charges to begin detonating around them. Instead, they heard the corvette's propellers maintaining a steady bearing, not moving away as they would after dropping depth charges. Then another series of splashes, closer this time. Weber ordered another course change, going deeper, pushing his boat toward its maximum safe depth of 230 meters. The third salvo found them. Weber later reported that he heard 3 distinct explosions, very close together, that sounded different from any depth charge he had experienced. His boat shuddered, and he felt the pressure wave even though the projectiles hadn't made direct contact. One had apparently struck a glancing blow against the conning tower, causing minor damage but not penetrating. Another had missed by mere feet. The third had struck the aft deck plating but had hit at such an angle that it ricocheted off without detonating properly. Weber's boat survived, but barely. He was forced to surface and surrender, his submarine too damaged to continue combat operations. During his interrogation, Allied intelligence officers were surprised to learn how little the Germans understood about the Hedgehog. Weber described the weapon in terms that showed he thought it was some kind of advanced depth charge, not understanding the contact detonation principle or the forward-throwing capability. His report, when it reached German naval headquarters, was one of the first detailed accounts of the weapon, but by then dozens of U-boats had already been sunk by it. German U-boat command tried to develop countermeasures, but what could they do? The fundamental problem was that the Hedgehog attacks were based on accurate sonar tracking, and there was no practical way to jam or deceive the sonar systems of the era. U-boats could go deep, but deeper diving just meant the projectiles would strike with even more force, and the boat would be under greater pressure from the surrounding water when its hull was breached. U-boats could stay shallow, but that made them easier to detect and gave them even less time to react. Some commanders tried zigzagging evasive patterns, constantly changing course to make their position harder to predict. This sometimes worked against depth charge attacks, but it was less effective against the Hedgehog because the weapon was launched while the attacking ship still had solid sonar contact. The projectiles weren't aimed at where the submarine had been, they were aimed at where it was right now. The German Navy experimented with various defensive measures. One idea was to coat the submarine's hull with rubber tiles that might absorb sonar pings, making the boat harder to detect. This worked to some degree against older sonar systems, but the improved ASDIC sets used by Allied escorts in 1943 and 1944 could still detect rubber-coated submarines at tactically useful ranges. The rubber coating also added weight to the submarine, reducing its speed and maneuverability, which made it even more vulnerable once detected. Another attempted countermeasure was the bold decoy, a canister that could be ejected from the submarine and would release a cloud of chemicals that created bubbles in the water. These bubbles would reflect sonar waves, creating a false target that might draw the attacking ship away from the real submarine. Bold decoys worked reasonably well against depth charge attacks, because once the attacking ship lost sonar contact passing over the submarine, the decoy could create enough confusion to allow the U-boat to escape. But against the Hedgehog, where sonar contact was never lost, bold decoys were less effective. The sonar operator could often distinguish between the genuine submarine contact and the decoy, and even if there was momentary confusion, the attacking ship could simply fire Hedgehog salvos at both contacts. The introduction of the Hedgehog coincided with several other improvements in Allied anti-submarine warfare, creating a synergistic effect that was absolutely devastating to the U-boat fleet. Better radar allowed surface ships to detect submarines running on the surface at night. The Germans had initially believed their submarines were invisible in darkness, but by 1943, Allied ships equipped with centimetric radar could detect a surfaced U-boat at ranges of several miles, even in complete darkness or heavy weather. Improved sonar gave more accurate range and bearing information. Early ASDIC sets had been plagued by problems with accuracy and reliability, often giving false contacts or losing track of genuine targets. By 1943, new models with better electronics and trained operators could track a submarine with enough precision to guide a Hedgehog attack with lethal accuracy. The integration of sonar data with fire control systems meant that the time from detection to attack had been dramatically reduced. Longer-range patrol aircraft equipped with better depth charges and homing torpedoes closed the mid-Atlantic gap where U-boats had previously operated with relative impunity. For years, there had been a zone in the middle of the Atlantic that was beyond the range of land-based aircraft, giving U-boats a safe area where they could surface, recharge batteries, and attack convoys without fear of air attack. But with the deployment of very long-range patrol aircraft like the B-24 Liberator, equipped with additional fuel tanks, this gap was closed. U-boats could now be hunted anywhere in the Atlantic, and tying all of this together was the Hedgehog, providing a way to kill submarines quickly and efficiently once they were detected. The weapon became the final link in a kill chain that started with detection by radar or sonar, continued with tracking and fire control, and ended with destruction by contact-fused projectiles that gave the target no chance to escape. The statistics tell the story. In the first year of Hedgehog deployment, the success rate per attack was around 5%, which might not sound impressive until you realise that the success rate for depth charge attacks was under 1%. As crews became more experienced with the weapon and tactics were refined, the Hedgehog's success rate climbed to over 20% by 1944. This meant that 1 out of every 5 Hedgehog attacks resulted in a confirmed U-boat kill. Compare this to depth charges, which required multiple attack runs and hundreds of charges to achieve the same result. More significantly, the Hedgehog allowed smaller escorts with less experienced crews to achieve kills that would have been impossible with depth charges alone. A corvette with a crew that had been together for only a few months could sink a U-boat commanded by a veteran captain with years of experience, simply because the Hedgehog negated so many of the advantages that experience and skill had previously provided. The weapon was a great equalizer, and it helped compensate for the fact that Allied escort forces had expanded so rapidly that many ships were crewed by men with minimal training. The production and deployment of the Hedgehog was one of those wartime success stories that involved brilliant design, rapid manufacturing, and effective distribution. The weapon was conceived in 1940 when Britain was facing potential defeat in the Battle of the Atlantic. U-boats were sinking merchant ships faster than they could be replaced, and the existing anti-submarine weapons weren't effective enough to turn the tide. A British military engineer, Member of Parliament named Charles Goodeve, and his team at the Department of Miscellaneous Weapons Development came up with the initial concept. The department itself was an interesting organisation, tasked with developing unconventional weapons and solutions to military problems that didn't fit neatly into existing research programs. The Hedgehog was exactly the kind of lateral thinking solution they specialised in. Goodeve and his team were looking for a way to attack submarines ahead of the ship, maintaining sonar contact throughout the attack. The spigot mortar design they settled on was elegant and practical. Each projectile sat on a rod called a spigot that contained a small propellant charge. When fired, the charge would launch the projectile up and forward in a ballistic arc. The system was simple enough to be manufactured quickly and cheaply, robust enough to work reliably in the harsh conditions of the North Atlantic, and effective enough to kill submarines. The contact detonation feature was crucial to the design. If the projectiles had been set to detonate at specific depths like depth charges, they would have created explosions that interfered with sonar, making it impossible to tell whether you had hit the target or not. With contact detonation, the system was self-reporting. Hit or miss, you knew immediately. If there was an explosion, you'd sunk a submarine. If there was silence, you prepared another salvo and adjusted your aim. The development process was remarkably rapid by the standards of military procurement. The concept was proposed in early 1941, prototypes were tested by mid-1941, and the first production units were being installed on ships by late 1941. This speed was partly due to the desperate situation Britain faced. The U-boat threat was existential. If the Atlantic supply lines were cut, Britain would be starved into submission. There was no time for lengthy development cycles or extensive testing. The Hedgehog had to work, and it had to work now. The first Hedgehog systems were installed on British destroyers and corvettes in late 1941, but it took time for crews to learn how to use the weapon effectively. Early attacks had very low success rates because crews were still learning the proper firing procedures, range estimation, and timing. The weapon required coordination between the sonar operator, the fire control officer, and the Hedgehog crew. If any part of this chain failed, the attack would miss. Training programs were established to teach escort crews how to use the Hedgehog effectively. Mock attacks were conducted using friendly submarines as targets, with the Hedgehog firing practice projectiles that were filled with sand instead of explosives. These exercises revealed the importance of timing and fire control. The attacking ship had to maintain a steady course and speed during the attack, giving the sonar operator a stable platform for tracking. The fire control officer had to calculate the correct lead angle, accounting for the submarine's movement during the time it took for the projectiles to reach the target. By mid-1942, the weapon was proving its worth, and production was ramped up dramatically. British shipyards, already working at maximum capacity to build escorts and repair damaged ships, added Hedgehog production to their workload. The weapon's relatively simple design meant it could be manufactured by facilities that weren't equipped for complex weapons production. Small engineering firms, railway workshops, and even agricultural equipment manufacturers were contracted to produce components. American shipyards began producing Hedgehog systems under license, and the weapon was installed on hundreds of Allied escorts throughout 1942 and 1943. The United States had entered the war in December 1941, and American industrial capacity was now being brought to bear on the Battle of the Atlantic. American-built destroyer escorts, a class of smaller, cheaper anti-submarine ships, were being launched at a rate of several per week, and most were equipped with Hedgehog from the moment they were commissioned. By 1944, most frontline anti-submarine vessels in the Atlantic carried either Hedgehog or its later variant, the Squid, which fired larger projectiles in a smaller pattern. The weapon became so important to the anti-submarine campaign that ships equipped with Hedgehog were prioritized for convoy escort duties and submarine hunting patrols. Older escorts that hadn't been fitted with the weapon during construction were recalled to shipyards for retrofitting when possible. The logistics of keeping hundreds of Hedgehog-equipped ships supplied with ammunition was a significant challenge. Each projectile had to be manufactured to precise specifications to ensure consistent performance. The contact fuses were delicate mechanisms that required careful handling and storage. The Torpex explosive filling was dangerous to work with and had to be loaded into the projectile bodies under strictly controlled conditions. Despite these challenges, the Allied logistics system managed to keep the weapon supplied, another testament to the industrial and organizational superiority that ultimately won the war. From the German perspective, the introduction of the Hedgehog was one more nail in the coffin of the U-boat campaign. Grand Admiral Karl Dönitz, commander of the U-boat fleet, had bet everything on the ability of his submarines to strangle Britain by cutting off its Atlantic supply lines. In 1942, this strategy appeared to be working. U-boats were sinking over 600,000 tons of Allied shipping per month, and new submarines were being launched faster than they could be destroyed. Dönitz was a true believer in submarine warfare. He had commanded U-boats during World War I and had spent the interwar years developing the tactics and doctrines that would guide the German U-boat fleet in the next conflict. His Wolfpack tactics, where multiple submarines would coordinate their attacks on a single convoy, had proven devastatingly effective in the early years of the war. He believed that if he could sink ships faster than the Allies could build them, Germany would win the Battle of the Atlantic and potentially the entire war. But 1943 saw a dramatic reversal. Allied convoy losses dropped sharply while U-boat losses skyrocketed. In May 1943 alone, 41 U-boats were sunk, a catastrophic loss rate that forced Dönitz to temporarily withdraw his submarines from the North Atlantic. The survivors who made it back to base told stories of a transformed battlefield where the Allies seemed to have answers to every German tactic. They described new weapons, better detection systems, and a level of coordination that made successful attacks almost impossible. While many factors contributed to this reversal, the Hedgehog was a significant piece of the puzzle, providing a reliable way to kill submarines once they were detected. Dönitz and his staff studied the intelligence reports about this new weapon, trying to understand its capabilities and develop countermeasures. But the more they learned, the more they realized how fundamentally the Hedgehog had changed the tactical equation. The psychological impact on U-boat crews cannot be overstated. These men were already operating under incredible stress, sealed inside steel tubes beneath hundreds of feet of dark water, hunted by increasingly sophisticated enemies, with death always just one mistake or one unlucky moment away. The old depth charge attacks had been terrifying, but at least comprehensible. You could hear them coming, feel your captain trying to save you, and maintain some sense of agency in your own survival. The Hedgehog removed that sense of agency almost completely. When a Hedgehog attack came, there was nothing you could do. You were too deep to surface and surrender, too slow to outrun the projectiles, and unable to maneuver effectively in the few seconds available. Your survival depended entirely on whether the Allied sonar operator had calculated your position accurately and whether the Hedgehog crew had aimed their launcher properly. You had no control, no way to fight back, no clever tactics to employ. You could only wait to see if death would arrive in the next few seconds. Life aboard a U-boat had never been pleasant, but by 1943 it had become almost unbearable. The boats were cramped, with barely enough space for the crew to move around. The air was thick with the smell of diesel fuel, unwashed bodies, and the chemical toilets that were the only sanitation facilities. Food was monotonous and often spoiled. Fresh water was severely rationed. Men lived in constant fear, knowing that at any moment sonar might detect them and an attack would begin. The introduction of the Hedgehog added a new dimension to this fear. Depth charge attacks, however terrifying, at least gave the crew something to do. They would race to their stations, the captain would bark orders, the boat would maneuver violently, and everyone would brace for the explosions. There was action, purpose, a sense that what they did mattered. But when a Hedgehog attack came, all they could do was wait. The crew would stand frozen at their stations, listening to the splashes above, waiting to see if the next sound they heard would be the last sound they ever heard. Some U-boat veterans later described the difference between depth charge attacks and Hedgehog attacks in terms that revealed their psychological state. Depth charges were fair in a strange way. You had a fighting chance. Your skill, your boat, and your captain's decisions mattered. But the Hedgehog was described as execution, as murder, as unfair. These words reveal how deeply the weapon had shaken the U-boat crew's understanding of naval combat. They felt helpless in a way they never had before. The technical specifications of the Hedgehog made it a marvel of practical engineering. Each launcher held 24 projectiles arranged in 4 rows of 6. The projectiles themselves were teardrop-shaped, designed to sink nose first and maintain a predictable trajectory through the water. The shape was carefully calculated to provide the right balance between drag and stability. Too much drag and the projectiles would slow down excessively during their underwater travel. Too little stability and they might tumble or veer off course. The nose contained the contact fuse, a mechanical device that would trigger the Torpex explosive charge the instant it felt significant resistance, which meant impact with the submarine's hull. The fuse design was critically important because it had to be sensitive enough to detonate on contact with the submarine, but not so sensitive that it would detonate prematurely from the shock of hitting the water or from water pressure as the projectile sank. British engineers spent considerable time perfecting this fuse, testing numerous designs before settling on one that was reliable and safe to handle. The projectiles were fired in a ripple pattern, launching in sequence with precisely timed delays between each shot. This created the elliptical impact pattern on the water's surface, giving coverage of an area large enough to account for minor inaccuracies in the sonar data, but small enough that the pattern remained concentrated on the target. The entire salvo would be in the air in less than 2 seconds, and all 24 projectiles would splash down within a 3-second window. The timing mechanism that controlled the ripple fire was itself a minor masterpiece of mechanical engineering. It used a series of cams and levers to trigger each mortar in sequence, with timing precision measured in fractions of a second. The mechanism had to work reliably in all weather conditions, from tropical heat to Arctic cold, in calm seas and in violent storms. It had to function when soaked with salt spray, when covered in ice, when the ship was rolling heavily in rough seas. The fact that it did work, consistently and reliably, is a testament to the quality of British engineering during the war. Once in the water, the projectiles sank at a rate of about 23 feet per second. For a submarine at standard periscope depth of 60 feet, this meant impact would occur in less than 3 seconds after splashdown. For a submarine at deeper depths of 150 to 200 feet, impact would occur in 7 to 9 seconds. Even at the maximum depth many U-boats could operate, around 750 feet, the projectiles would reach them in about 33 seconds. These timings were critical to understanding why the weapon was so deadly. Human reaction time, even for a well-trained U-boat crew already at action stations, was at least 2 to 3 seconds from the moment they heard the splashes to the moment the boat would begin responding to evasive orders. The captain had to recognize the sound, process what it meant, formulate a response, and give orders. The helmsman had to hear the orders, understand them, and begin moving the controls. The boat itself had to begin responding to the control inputs, overcoming its own inertia and the resistance of the water around it. By the time the boat was actually changing course or depth, the projectiles were already nearly on top of them. At periscope depth, it was literally impossible to evade. The projectiles would reach the submarine before the boat could move more than a few feet from its initial position. At deeper depths, you might have 5 or 6 seconds of actual maneuvering time, but in those few seconds, a submarine could not move far enough to escape the 40-yard impact pattern. The Torpex explosive used in Hedgehog projectiles deserves special mention. Torpex was developed specifically for underwater use and was significantly more powerful than TNT. 35 pounds of Torpex delivered roughly the same explosive force as 52 pounds of TNT. But the real advantage of Torpex was its performance under pressure. Deep underwater, where the surrounding water pressure was immense, Torpex maintained its full explosive power, whereas some other explosives became less effective. This made it ideal for anti-submarine work where the target might be hundreds of feet below the surface. The composition of Torpex was RDX, TNT, and aluminum powder in specific proportions. The RDX provided the primary explosive force, the TNT served as a binder and secondary explosive, and the aluminum powder increased the total energy output and enhanced the underwater shockwave. When detonated underwater, Torpex created a bubble of superheated gas that expanded violently, then collapsed just as violently, creating a secondary shockwave. This double shockwave effect was particularly destructive to submarine hulls. When a Hedgehog projectile struck a submarine's pressure hull, the shaped charge design focused the explosive force inward, punching through the thick steel plating that was designed to withstand the crushing pressure of the deep ocean. The steel used in U-boat hulls was specially hardened and could be over an inch thick in critical areas. It was designed to resist depth charge explosions from outside and water pressure from all directions. But it wasn't designed to resist a shaped charge detonating in direct contact with the hull. Once the hull was breached, several catastrophic things happened simultaneously. First, the explosive force itself would tear apart everything in the immediate vicinity, killing crew members and destroying equipment. The blast wave would propagate through the submarine's interior, rupturing eardrums, collapsing lungs, and causing massive internal injuries to anyone nearby. Equipment would be torn from its mountings, pipes would rupture, electrical systems would short-circuit in cascades of sparks. Second, the overpressure wave would propagate through the submarine's interior, rupturing bulkheads and crushing compartments. A submarine's interior was subdivided into watertight compartments, separated by heavy bulkheads that could be sealed with watertight doors. This compartmentalization was designed to contain flooding if the hull was breached in one area. But a Hedgehog explosion was so violent that it could damage or destroy multiple bulkheads simultaneously, defeating the compartmentalization and allowing flooding to spread throughout the boat. Third, and most deadly of all, the ocean would begin pouring in through the breach. At depth, the water pressure outside a submarine was enormous. At 200 feet down, every square inch of the submarine's hull experienced pressure of over 87 pounds. This meant that water flooding in through a breach didn't just flow, it exploded into the interior like a fire hose. A hole just a few inches across could flood an entire compartment in seconds. The weight of the incoming water would drag the submarine down, increasing the pressure and making the flooding worse. This was called going below crush depth, and once it started, it was almost impossible to stop. The submarine would spiral down into the dark depths until the hull finally imploded, crushing everything inside in an instant of unimaginable force. The pressure hull would buckle and collapse like a tin can, and the submarine would be compressed into a twisted mass of metal that would sink to the ocean floor. The lucky crews were the ones killed instantly by the initial explosion. The unlucky ones survived the hit and spent their last minutes trapped in a sinking submarine, listening to water rushing in and steel groaning under stress, knowing there was no escape and no hope of rescue. Some boats had emergency escape equipment, but at the depths where most attacks occurred, and with the boat in its death spiral, escape was impossible. The water pressure at depth was so great that opening an escape hatch would result in instant death from the pressure differential. Even if a crew member somehow managed to get out of the sinking submarine, their chances of survival were minimal. They would be hundreds of feet below the surface in the freezing waters of the North Atlantic, with no life raft, no supplies, and probably suffering from injuries sustained during the attack. The ascent to the surface, if too rapid, would result in decompression sickness, the bends, which could kill or cripple. And even if they reached the surface alive, the cold water would kill them in minutes unless they were immediately rescued. Allied escort commanders quickly learned the telltale signs of a successful Hedgehog attack. The immediate explosion was the first indicator, but it was often followed by a series of secondary explosions as the submarine's torpedoes detonated, its batteries short-circuited and exploded, and its compressed air tanks ruptured. These secondary explosions could continue for several minutes after the initial hit, each one marking another stage in the submarine's destruction. Oil and debris would rise to the surface, concrete evidence that the submarine had been destroyed. The oil would spread across the surface in an iridescent slick that could be seen for miles. The debris field would include pieces of the submarine's equipment, personal effects of the crew, and sometimes larger structural components that had been blown free during the destruction. Sometimes larger pieces would surface: life jackets, wooden furniture, bits of equipment, and occasionally heartbreakingly bodies. The protocol for confirming a kill was strict. The attacking ship would circle the area, using sonar to verify that the submarine contact had disappeared. They would document the debris field, sometimes retrieving pieces for intelligence purposes. Naval intelligence was intensely interested in any pieces of German equipment that could be recovered, as they might reveal details about U-boat construction, weapons systems, or electronic equipment. Personal effects were also collected when possible, as they could help identify which U-boat had been sunk and provide information about crew morale and living conditions. If there was any doubt, additional attacks might be made, or the area would be monitored for several hours to see if the submarine resurfaced. U-boats were known to play dead, lying motionless on the bottom and hoping the attacking ship would give up and leave. To counter this tactic, escort commanders would sometimes drop additional depth charges or fire another Hedgehog salvo at the location of the last contact just to be certain. Only when the escort commander was confident that the submarine had been destroyed would the kill be officially claimed. These confirmations were important because the Allies needed accurate data on their anti-submarine campaign's effectiveness. Early in the war, there had been problems with overclaiming, where escort commanders reported submarine kills that later proved to be false. Sometimes the sonar contact had been a whale or a school of fish. Sometimes the oil on the surface had been released deliberately by a damaged but still functional U-boat trying to fake its own destruction. Sometimes the wreckage was from a merchant ship sunk days earlier, not from a submarine at all. This overclaiming led to an overly optimistic assessment of how many U-boats remained operational, which in turn led to poor strategic decisions. Convoys might be routed through areas believed to be clear of submarines but that actually still had active U-boats patrolling. Resources might be allocated based on false assumptions about the effectiveness of anti-submarine measures. By 1943, the confirmation process was much more rigorous, and the data being collected was reliable enough to guide strategy at the highest levels. The German U-boat command tracked their losses carefully, and by late 1943, they knew they were losing the Battle of the Atlantic. The mathematics were brutal. New U-boats were being commissioned at a steady rate, but losses had accelerated to the point where the operational fleet was actually shrinking. Worse, the experienced commanders who had survived the early years of the war were being killed off, replaced by younger, less experienced captains who had little chance of surviving their first few patrols. The training program for new U-boat commanders had been shortened dramatically to meet the demand for replacements. Where early war commanders had spent months in training, learning their craft under the guidance of veterans, by 1943 new commanders might have only a few weeks of training before being given command of a submarine and sent into combat. These inexperienced captains made mistakes that veterans would never have made, and they died as a result. Dönitz tried various countermeasures. U-boats were equipped with snorkels, allowing them to run their diesel engines while submerged just below the surface, reducing their time on the surface where they were vulnerable to radar detection. The snorkel was essentially a long tube that extended above the surface, bringing air down to the submarine so the diesels could run while the boat remained submerged. This dramatically reduced the U-boat's radar signature and made them much harder to detect. But the snorkel had its own problems. It was visible from a distance, appearing as a small projection above the water that could be spotted by alert lookouts. It also created a distinctive wake that could be seen from aircraft, and when the boat was operating at snorkel depth, it was vulnerable to hedgehog attacks just as much as when it was at periscope depth. The snorkel helped with detection, but it didn't help with survival once detected. New torpedo designs were introduced, including acoustic homing torpedoes that could hunt Allied escorts. The T-5 Zaunkönig torpedo was designed to home in on the sound of a ship's propellers, allowing U-boats to fire from longer range and potentially sink escorts before they could launch a hedgehog attack. In theory, this was a game changer. In practice, the Allies quickly developed countermeasures, including noisemakers towed behind escorts that would attract the acoustic torpedoes away from the actual ship. U-boats were assigned to operate in wolf packs, coordinating their attacks to overwhelm convoy defences. The wolfpack tactic had been devastatingly effective in 1941 and 1942, when multiple U-boats would gather around a convoy and attack simultaneously, creating chaos and making it impossible for the limited number of escorts to protect all the merchant ships. But by 1943, convoys had more escorts, better coordination, and weapons like the Hedgehog that made concentrated attacks suicidal. None of it was enough. The Allies had achieved dominance in anti-submarine warfare through a combination of better technology, better tactics, and industrial might that could produce escorts faster than Germany could produce U-boats. The Hedgehog was just one weapon in this arsenal, but it was a critical one, providing the killing stroke once a submarine had been detected and tracked. By 1944, the average U-boat survived only a handful of patrols before being sunk. The life expectancy of a U-boat crew member was measured in months, not years. Morale in the U-boat service plummeted. These men knew they were going out to die. They knew the Allies had weapons and technologies that made survival increasingly unlikely, but they went anyway, because that was their duty, and because refusing meant execution for cowardice. The selection process for U-boat crews had changed dramatically as the war progressed. In the early years, serving in the U-boat arm was considered an elite assignment. Volunteers were plentiful, and only the best were selected. The men who crewed U-boats in 1940 and 1941 were highly trained, highly motivated, and proud of their role in what they believed would be Germany's victory. By 1944, volunteers were scarce, and men were being assigned to U-boat duty whether they wanted it or not. The training these later crews received was abbreviated and inadequate. There simply wasn't time to properly train new crews when submarines were being lost at such a high rate. Men who in peacetime would have spent a year or more learning their trade were being sent into combat after a few months of hasty instruction. They didn't know their boats as intimately as the early war crews had. They didn't have the experience to handle emergencies, and when the Hedgehog found them, they died just as quickly as the veterans had. The ethical dimension of this is worth considering. The Hedgehog was devastatingly effective, but it was also merciless. The contact detonation design meant that crew members trapped in a damaged but not immediately sinking submarine had no real hope. Unlike depth charge attacks, which might damage a submarine enough to force it to surface and surrender, a Hedgehog hit was almost always fatal. The weapon gave no quarter, no chance for surrender, no possibility of survival. From the Allied perspective, this was exactly what they wanted. U-boats had been sinking merchant ships and killing Allied sailors by the thousands. These submarines were weapons of war, and destroying them completely was the whole point. The goal wasn't to capture U-boats or take prisoners, it was to eliminate the threat to the Atlantic supply lines. The Hedgehog accomplished this goal with brutal efficiency. The merchant seamen who crewed the cargo ships crossing the Atlantic had no sympathy for U-boat crews. These merchant sailors had watched their friends die when torpedoes tore their ships apart. They had floated in lifeboats in the freezing Atlantic, watching men die of hypothermia because there wasn't room in the boats for everyone. They had seen ships loaded with fuel oil explode in fireballs that cremated everyone aboard in seconds. They had pulled burned and drowning men from the water, knowing that most wouldn't survive. From their perspective, any weapon that killed U-boats was a good weapon. From the German perspective, and from a humanitarian standpoint, the Hedgehog represented a kind of warfare that seemed particularly cruel. But this perception was more about psychology than reality. Depth charges killed just as thoroughly when they struck close enough to a submarine. The difference was that depth charges gave the illusion of a fighting chance, whereas the Hedgehog removed even that cold comfort. The U-boat crews weren't actually any more dead when killed by a Hedgehog than when killed by depth charges. They just had less time to hope they might survive. The development of the Squid anti-submarine mortar in 1943 took the Hedgehog concept and refined it further. The Squid fired only 3 projectiles instead of 24, but each projectile was much larger, carrying 200 pounds of explosive instead of 35. The projectiles were fired in a triangular pattern and used depth fuses rather than contact detonation, because the larger explosive charges didn't need direct contact to destroy a submarine. A Squid projectile exploding within 50 feet of a U-boat would crush its hull through sheer hydraulic shock. The Squid was even more accurate than the Hedgehog because it used an automated fire control system that could predict the submarine's future position and adjust aim accordingly. The system, called a Q attachment, was essentially a mechanical computer that took inputs from the sonar operator about the submarine's range, bearing, depth, and speed, calculated where the submarine would be in the next few seconds, and automatically aimed and fired the Squid to hit that predicted position. This level of automation was remarkable for its time. Remember, this was 1943, decades before electronic computers became commonplace. The Q attachment was a mechanical analog computer that used gears, cams, and differential mechanisms to perform the necessary calculations. It wasn't perfect, and it required skilled operators to input the correct data, but when it worked, it was devastatingly effective. But the Hedgehog remained in service throughout the war and for decades afterward because it was simpler, cheaper to produce, and didn't require the sophisticated fire control computers needed for the Squid. Many smaller escorts that couldn't accommodate the Squid system were equipped with Hedgehog instead, giving them a credible anti-submarine capability that far exceeded the old depth charge armament. Even ships that were equipped with Squid often retained their Hedgehog launchers as backup weapons. The legacy of the Hedgehog extends beyond World War II. The weapon demonstrated the value of forward-throwing anti-submarine mortars, a concept that influenced naval weapons development for generations. The principle that maintaining sensor contact throughout an attack dramatically improves effectiveness became a fundamental tenet of anti-submarine warfare. Every modern anti-submarine weapon system, from rocket-launched torpedoes to vertical-launch ASROC missiles, embodies this principle. The Australian Ikara missile system, developed in the 1960s, was a direct descendant of the Hedgehog concept. Ikara was a guided missile that would fly to the vicinity of a submarine contact and drop a homing torpedo into the water. The launching ship maintained sonar contact throughout the missile's flight and could update its targeting data in real time. Various rocket-propelled depth charge launchers developed during the Cold War all used the forward-throwing principle pioneered by the Hedgehog. The Hedgehog also demonstrated the importance of weapon-target coordination. Earlier anti-submarine weapons had been designed in isolation, without sufficient consideration for how they would integrate with sensors and fire control systems. The Hedgehog was designed from the beginning to work seamlessly with ASDIC sonar, creating a unified system where detection, tracking, and attack were all part of a coordinated whole. This systems thinking approach became standard in naval weapons development and extended to all military technologies. Modern naval warfare has moved far beyond the Hedgehog, with sophisticated sonar systems, computer-controlled weapons, and guided torpedoes that can hunt their targets autonomously. But the fundamental principles pioneered by the Hedgehog remain valid. Maintain sensor contact. Attack from a position where you don't lose that contact. Use weapons that give immediate feedback on whether you've hit or missed. These principles seem obvious now, but they were revolutionary in 1942, and they changed naval warfare forever. For the U-boat crews who faced the Hedgehog, these broader considerations meant nothing. What mattered was the immediate visceral terror of facing a weapon they couldn't understand, couldn't predict, and couldn't survive. Kapitan Lieutenant Steinhoff's confusion in those final seconds aboard U-432 was shared by hundreds of other commanders who died the same way. They had entered a new kind of warfare, one where the old skills and tactics no longer mattered. where experience counted for nothing and where death came too fast to comprehend. The statistical record bears this out. Of the approximately 780 U-boats lost during World War II, at least 47 were confirmed kills by Hedgehog, with many more probable kills where the weapon was involved, but confirmation was incomplete. This might not seem like a large percentage, but it represents an enormous return on investment. The Hedgehog was relatively cheap to produce and deploy, required no special skills to operate beyond basic anti-submarine training, and had a success rate far higher than any previous anti-submarine weapon. More importantly, the Hedgehog's presence forced changes in U-boat tactics that made them less effective overall. U-boats had to operate deeper to try to gain a few extra seconds of warning before Hedgehog projectiles reached them. But operating deeper meant they couldn't use their periscopes effectively, and had to rely on sonar, which was less capable than visual observation. U-boats had to be more cautious about approaching convoys, knowing that if they were detected they would probably die. This caution meant fewer attacks, fewer sinkings, and ultimately the failure of the U-boat campaign. The human cost was staggering. Approximately 30,000 German submariners died during World War II, most of them in the Atlantic. These were not abstract statistics, but real men, many of them teenagers, who died in the cold, dark depths far from home. Some died instantly when Hedgehog projectiles found their boats. Others died slowly as their submarines sank into the abyss, water flooding in around them, pressure increasing until the hull could take no more. Still others survived the sinking only to die of hypothermia in the frigid Atlantic waters, waiting for rescue that would never come. On the Allied side, the merchant seamen and naval personnel who crewed the ships that hunted U-boats also paid a price. Even with weapons like the Hedgehog, anti-submarine warfare remained dangerous. U-boats could still sink escorts, and many Allied sailors died in these actions. The psychological stress of constant vigilance, knowing that at any moment a torpedo might strike, took its toll on crews. But as the war progressed and weapons like the Hedgehog shifted the balance of power, Allied losses decreased while German losses mounted. The Battle of the Atlantic was ultimately won by the Allies, and while no single weapon or technology can claim credit for that victory, the Hedgehog played a crucial role. It provided a way to convert detection into destruction, turning the improved radar and sonar capabilities of Allied escorts into actual sinkings rather than just unsuccessful attacks. It forced the U-boat fleet to operate under conditions of such extreme danger that effective combat operations became nearly impossible, and it did all of this with a design that was relatively simple, cheap to produce, and easy to deploy on a wide range of vessels. The weapon's simplicity was one of its greatest strengths. Unlike complex weapon systems that required extensive maintenance and highly trained specialists, the Hedgehog could be operated by ordinary seamen with basic training. The mechanical systems were robust and reliable, working in conditions that would have disabled more sophisticated equipment. The ammunition was stable and safe to handle, reducing the risk of accidents, and when the weapon was fired it either worked or it didn't, with no ambiguity. This reliability and simplicity meant that the Hedgehog could be deployed widely across the Allied escort fleet, giving even small corvettes with inexperienced crews a credible anti-submarine capability. It democratized anti-submarine warfare in a way, making effectiveness less dependent on having veteran crews or elite ships. A brand new corvette with a crew that had been together for only a few weeks could sink a U-boat commanded by an ace with years of experience, simply because the Hedgehog negated so many of the advantages that skill and experience had previously provided. In 90 seconds or less, the Hedgehog could send a U-boat and its entire crew to the bottom of the Atlantic. No warning, no escape, no mercy. Just the peculiar sound of 24 projectiles splashing into the water above, and then either silence or death. For the German U-boat captains who encountered this weapon, those 90 seconds represented everything that had gone wrong with their campaign. Everything that had changed in the technology and tactics of naval warfare, and everything they had failed to understand until it was too late. The Hedgehog was more than just a weapon. It was a symbol of the Allied advantage in research, development, and industrial production. It represented the kind of innovative thinking that characterized the Allied war effort, where unconventional solutions to difficult problems were encouraged and rapidly implemented. It demonstrated the value of integrating weapons with sensors and fire control systems, a lesson that would shape military technology for decades to come. and it showed that in modern warfare, technological superiority could overcome numerical advantages and tactical skill. For the historians and military analysts who study the Battle of the Atlantic, the Hedgehog represents a case study in how a single weapon system can have strategic impact far beyond its immediate tactical effects. By making U-boat operations more dangerous, it forced changes in German strategy and tactics. By improving the effectiveness of Allied escorts, it allowed convoys to be defended with fewer ships, freeing up resources for other operations. By providing reliable kills, it helped turn the tide of the longest battle of World War II. But for the men who fought and died in that battle, the Hedgehog was much simpler. For Allied sailors, it was hope, a weapon that might save their ship when a U-boat attacked. For German submariners, it was death, arriving too fast to understand or evade. The legacy of the Hedgehog is written in steel and fire at the bottom of the Atlantic Ocean, where hundreds of U-boats lie as testament to its effectiveness. Those rusting hulls scattered across the seabed are the final answer to the question that Kapitän-Leutnant Steinhoff never had time to ask. How had they known? How had the charges reached him so quickly? Why had there been no time to evade? The Hedgehog was the answer, and its impact echoes through naval history to this day.